The weight of absolute stillness presses gently upon you, a velvet pressure that absorbs all edges and sharp angles of thought. Close your eyes and picture a vast, breathable emptiness, a darkness so profound it has its own soft, resonant scent, like chilled ozone and distant, drifting minerals. Let the only sound be the breath you exhale, a warm tide rolling out into the cold expanse, guiding you deeper, slower, into the deep quiet. Chapter 1, The Veil of Initial Quiet. The story we are embarking upon is not one of fire or explosion, but rather one of lingering echo, a faint, persistent hush that permeates every corner of the cosmic darkness. We are going to map a light that has traveled for nearly 13 billion years, light that has endured the longest journey known in all of natural history. This uniform, gentle whisper is the signature of the universe's absolute beginning, a radiant afterglow known to us as the cosmic microwave background, or the CMB. Imagine, slowly, an emptiness so perfect, so smooth in its energy distribution, that it defies the complexity of our immediate existence. This energy bath, this residue of primordial heat, is scattered everywhere, a pervasive, invisible blanket woven into the very fabric of spacetime itself. It is not a visible source, like the fierce blaze of a distant star, but rather a whisper of heat, measured in infinitesimal increments, microkelvins, which speaks volumes about the state of everything that ever was. At first, the universe was a thing of pure, searing density, a blinding, superheated plasma where matter and energy were inseparable, vibrating together in a chaotic, brilliant froth. Existence, in that moment, was a brilliant, uniform soup, opaque to any individual form of light that might have once traveled through it. No true sky could be seen, only a blinding, dense whiteness, a curtain drawn too tightly to permit any view of what lay beyond. We are charting the moment when that dense plasma finally transitioned, when the curtain was allowed to lift just enough for light itself to begin a true journey. This moment, designated epically, remains one of the most profound and delicate transitions in the physics of scale. A shift from an opaque, glowing fog into a transparent, expanding void. The concept of the CMB requires us to gently rewind our perception of time, to drift back to a time less easily contained by physical measure, a cosmic memory stored in photons. We are following those photons now, those earliest travelers, those spectral wanderers that began their meandering journeys in the intense, suffocating confinement of the early cosmos. They retain the memory of the primordial heat, a memory that persists with an astonishing fidelity across unimaginable gulfs of distance. Chapter 2, The Epoch of Decoupling. For the first hundreds of thousands of years, the universe existed in a state of intense, blinding thermal equilibrium, a plasma sea where electrons, protons, and photons were bound in a constant, violent collision. Think of it as a magnificent, highly charged fog, a dense ocean of particles that meant that every photon, no matter where it was traveling, was doomed to scatter immediately upon encountering an electron or a free atomic particle. There was no straight line for light. There was only a continuous state of scattering, a universal kaleidoscope of charged particles in perpetual, rhythmic collision. The universe glowed with an unbearable, homogenized brilliance, a state of maximum energy density that speaks to a youth far beyond human comprehension. This was a time of universal coupling, where matter, energy, and light were entangled in a perfect, glowing grip. But the fundamental laws of physics, in their elegant, inexorable manner, dictated a slow, cooling drift. As the universe continued its expansive stretch, as the vacuum itself swelled and pulled matter further apart, the overall kinetic energy of the plasma began to diminish, cooling the vast, stellar ocean of charged particles toward a state of lower, yet still immense, volatility. And then, slowly, gracefully, over a span of an astonishingly short period, a mere fraction of a second, though astronomically significant, the critical tipping point approached. The temperature of the plasma began to cool to a precise threshold, allowing the fundamental particles of matter to finally bind together, pairing up in a much more stable and predictable configuration. This transition process is what we call recombination, and it is followed immediately by the event of decoupling. Recombination, the formation of the first stable, neutral hydrogen atoms, was the biological moment for the cosmos. These neutral atoms could finally cease their incessant scattering of freed electrons. When the free electrons were captured by hydrogen nuclei, the charged plasma fog began to dissipate, allowing a great, profound silence to settle over the energy field. And so, the photons, the ancient messengers, were suddenly freed. They were no longer trapped by the perpetual collisions, the cosmic cage finally opening up. This moment, the moment of decoupling, allowed the photons to stream outward instantaneously into a nearly empty, translucent medium, setting them finally upon the cosmic journey that has stretched across billions of years of expansion. Chapter 3, the snapshot of 380,000 years. This newfound freedom of the photons gave them the physical ability to travel unimpeded directly toward us, carrying with them the precise thermal fingerprint of the universe at the moment that transition occurred. This makes the CMB something unique. It is less a generalized glow and more a perfect time capsule, a highly detailed snapshot of the universe when it was precisely 380,000 years old. When we speak of this epoch, we are talking about a moment when the universe was still incredibly hot, but where the density of the interacting particles had finally dropped enough to allow for the vast, open lanes of spacetime to begin their quiet work of separation. The early cosmos, for the first time, possessed a transparent sky, a tenuous, glowing gas that filled the vacuum, ready to be painted by the cosmic breath. This light we observe today has been stretched, redshifted, cooled, and smoothed by the perpetual expansion of space itself. That initial, blinding flash of heat has been cooled by the factor of staggering cosmic expansion, arriving at us not as visible white light, but as gentle, predictable microwaves, a perfect, universal bath of energy. This remarkable cooling is what gives the CMB its signature frequency. The prevailing temperature of this residual energy is astonishingly beautiful in its consistency, approximately 2.725 degrees above absolute zero, a figure that evokes a profound sense of gentle stability and universal poise. This near-perfect reading is the signature of a near-ideal blackbody radiation curve, meaning the energy radiating through the void is distributed with an almost flawless predictability, a perfect thermodynamic song echoing from the beginning. If the universe were perfectly uniform, every single point within the CMB map would glow with the exact same, unwavering energy signature. It would be a perfect, monochromatic shield of thermal uniformity, a flawless sphere of radiant calm. The stunning initial thought, upon considering this energy, is the sheer, overwhelming implication of this uniformity, that the vast, colossal scale of the early universe was remarkably, almost impossibly, balanced. Yet, even in this tapestry of sublime uniformity, there exists a subtle, breathtaking imperfection. And it is in mapping these tiny, minute variations, these slight breathings of energy, that the deepest truths of cosmology begin to unfold. These deviations are the seeds, the whisperings of potential, the embryonic blueprints for everything that would eventually form. Chapter 4, The Whispers of Anisotropes. The minute variations in the CMB are what we refer to as anisotropes, the subtle variations in temperature or density across the observed sky. These differences are staggeringly small, measurable in mere microkelvin units, fractions of a degree that are nearly undetectable except through decades of precise, dedicated scientific measurement. To grasp the significance of a microkelvin shift, one must first grasp the profundity of the uniformity we just discussed. Imagine a vast, perfectly smooth sheet of water. The anisotropes are the faintest ripples barely disturbing the surface, ripples that could only have originated from the earliest, most subtle fluctuations in the fundamental scaffolding of the nascent cosmos. They are the universe's microscopic signature of imperfection, and those imperfections are everything. In the very early plasma, before recombination, the matter was not distributed perfectly. On some patches, the density of charged particles was infinitesimally higher than on others. These regions represent tiny pockets of slightly more energetic potential, and conversely, other patches were marginally quieter. These density variations formed initial gradients, gentle slopes in the otherwise perfectly flat expanse. These slight overdensities and underdensities did not simply disappear. They acted as tiny gravitational attractors. Over the subsequent eons, as the universe cooled through the recombination era and began its protracted, expanding dance, gravity took root in these slight imbalances. Matter, following the dictates of mass, began to flow outward from the slightly richer patches and gather inward toward the slight voids, beginning the slow, patient accumulation of mass over unimaginable stretches of time. This initial scaffolding, mapped in the temperature variations of the CMB, the first, faintest gradient, is the definitive evidence we possess for the structure of the large-scale cosmos. It provides the primary evidence that gravity is a continuous, structuring force, always pulling the most mass toward the deepest potential wells. These fluctuations are not random noise. They possess a profound, haunting order, a statistical rhythm that suggests an underlying, deeply physical principle governing them all. By mapping the pattern of the anisotropes, scientists were able to constrain the fundamental constants of nature, determining the precise ratio of matter to energy, the relative influence of dark matter, and the proportion of ordinary baryonic matter. Chapter 5, The Acoustic Echoes. The most remarkable aspect of the CMB anisotropes is not simply their existence, but the precise pattern they exhibit, a pattern that speaks volumes about the physical processes that were occurring in the primordial plasma, processes that sounded something like deep, universal pulsations. These patterns are often described in terms of acoustic oscillations. Before recombination, the plasma was hot, dense, and coupled. The photons, being highly energetic and strongly interacting, exerted an immense outward pressure, pushing the plasma outward. Meanwhile, the gravitational attraction of the slight overdensities within the plasma was constantly pulling everything back inward. This interaction between the relentless outward force of radiation pressure and the inward pull of gravity created a colossal, cosmic system of sound waves within the ionized plasma. Imagine a gigantic, submerged bell that is continuously struck by a powerful, cyclical force. That pulsation, operating across millions of light years, is what we detect today. These are not literal sound waves, but rather density waves, harmonic oscillations frozen into the light itself when the plasma suddenly cleared. The angular size and separation of the brightest peaks and dips on the CMB map hold the statistical keys to the physical conditions of that epoch. The location of the first major, dominant peak, for instance, tells us about the geometry of the universe, the measure of its overall curvature. The relative spacing of these peaks reveals the precise acoustic properties of the dense, primordial fluid. These peaks form a statistical fingerprint, a cosmic barcode. Analyzing the specific ratios between the first major acoustic peak, the secondary peak, and the tertiary peak allows cosmologists to calculate, with an incredible degree of precision, the energy density of the universe. It is through these acoustic echoes that we understand the relative proportions of matter, dark matter, and the energy inherent in the vacuum itself. Pause. 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 pause, 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 Pause. 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 pause, 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 Pause. 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 Pause, pause, pause. pause, 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 Pause. 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 pause, 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 pause. Conclusion. The study of the CMB, the cosmic microwave background, is one of the most profound and successful endeavors in modern cosmology. It provided definitive observational evidence supporting the Big Bang model and allowed scientists to map the universe at a moment when it was roughly 380,000 years old. The anisotropies, tiny temperature fluctuations, observed in the CMB are not random noise. They are encoded seeds of structure formation. The precise measurements of the power spectrum derived from these fluctuations allow cosmologists to calculate the fundamental parameters that define our physical reality: the age of the universe, the density of baryonic matter, the density of dark matter, and the geometric curvature of spacetime. In essence, CMB mapping is a cornerstone of modern cosmology because it provides a fossil record of the very earliest structure in the universe. It moves cosmology from theoretical speculation to empirically grounded science. The future study of CMB polarization, particularly the elusive B modes, which would signal primordial gravitational waves, holds the potential to revolutionize our understanding of cosmic inflation and physics at energy scales far beyond our direct reach. Ultimately, the CMB is a window into time, offering an unprecedented view into the origins and fundamental composition of the cosmos. Sound of a deep, resonant synthesizer chord, slowly building in pitch, followed by an echoing, ethereal whoosh sound, reminiscent of deep space. Narrator voice shifts, becomes calm, authoritative, and beautifully articulate, with a slight, inherent sense of awe. We journey now, not through history, but through asterisk time itself. We navigate the echo of the earliest moments, an era so distant, so vast, that our wildest imaginations struggle to pin down its reality. We speak of the cosmic dawn, the point when the universe exhaled light. The synthesizer chord resolves into a steady, low, humming resonance. A subtle sound effect of millions of distant, twinkling radio signals begins to overlay the hum. Narrator asterisk. For the first few 100,000 years, the cosmos was a blinding, opaque fog. A plasma soup so intensely energized that light, the very messenger of vision, could not travel freely. Every photon, upon its journey, was constantly scattered, absorbed, and redirected by the free-floating charges of the primal gas. It was a universe shrouded in a milky, blinding curtain. Then, the temperature began its slow, inexorable descent. The hum noticeably deepens, becoming more profound, almost like the turning of colossal, unseen machinery. Narrator asterisk. As the energy bled away, the charged particles, hydrogen and helium, slowly, gradually found enough peace to reconnect. They sought stability. They cooled into neutral atoms. The cosmic fog lifted. This moment, the epic of recombination ***, was not a sudden flash of brilliance, but a gradual, profound * clearing ***. It was the first great act of structure. The twinkling radio signals swell slightly, seeming to gain focus. A faint, rhythmic pop-pop-pop sound is layered in, like the steady arrival of energy packets. Narrator asterisk. Suddenly, the universe was translucent. Light streamed forth across unimaginable gulfs, unimpeded. These photons, escaping the gravitational embrace of their creation, continued to stream outward, cooling, stretching, and traveling through the darkness for the next 3/4 of the billion years. They carry with them the ghost echo of that birth, a whisper of the primordial soup. This lasting whisper, this faint, uniform static imprinted across the entirety of space, is what we call the cosmic microwave background radiation ***. The soundscape narrows down. The grand, celestial hum fades, replaced by a clear, crisp sound of steady, subtle static, the characteristic CMB signature. This static is played back, sounding incredibly ancient and pervasive. Narrator asterisk. It is the light of the baby universe. It is the photograph, taken at the moment the universe transitioned from an opaque haze to an open, visible expanse. Every speck of static you hear is the residual heat signature of every atom, scattering, finally settling into place. It is the oldest light we know, a testament to the fact that, at a moment in time, the universe breathed out a breath, and that breath remains, cool and constant, washing over us even today. The static sound slowly fades, the initial deep, resonant synthesizer chord returns, but now it sounds less like creation and more like deep, settled contemplation. The sound builds to a final, sustained, majestic note. Narrator asterisk. The silence following that initial resonance, that is where the drama truly began. The scaffolding for every star, every galaxy, and every life form, all began from the ripples within that ancient microwave echo. Final swell of sound, then a complete, reverent fade to silence.